So let's talk about a one-sample t-test using R. A t-test allows us to get evidence for or against a hypothesis population mean based on our sample mean, and it doesn't require our standard deviation like the z-test does. What it tells us is how likely our sample data is if our null hypothesis is true. So the steps of a t-test: first we want to state our null and alternative hypothesis, then we want to find the test statistic and the p-value, and then we want to interpret those results and use that to draw conclusions. Okay, let's look at an example. A coffee shop claims that their large coffee is 12 ounces, but you think that they're giving people less than that. So you buy 10 coffees and measure the volume of each. We want to decide if there's enough evidence to say that the mean volume is less than 12. So here are the volumes that you measured. Okay, so first step, state our null and alternative hypothesis. So our null hypothesis is that it is 12 ounces. They're not lying to us. Our alternative is that our mean is less than 12. Now in other cases this could be not equals or greater, but in this case we only care if they're underfilling. Next we want to find the test statistic and p-value. Our test statistic is kind of like a z-score. It tells us how many standard errors we are away from the mean. So for like at -2, we would be 2 standard errors below average. And our p-value is this little area, and it tells us the probability of seeing a sample like ours or more extreme if the null is true. So let's use R to find those. So going over to R, the first thing we want to do is read in our data. So I just called it data, but you can call it anything you want. And then I made a list by doing C, parentheses, and then all of our values separated by commas. And then when I run this, it should pop up over here in our global environment. Okay, now R has a really nice function called t.test. If we run this, it will give us our test statistic and our p-value just using this one simple function. So what we need is we need to put in our data and our null hypothesis, which is mu equals 12, and we need to specify the direction of our alternative hypothesis. So because we only care about underfilling, I'm just going to say less here. You could also do greater or two-sided for other types of alternative hypothesis. So when I run this, I get this output. So here we have our test statistic, our degrees of freedom, our p-value, our alternate, a confidence interval if we wanted to specify that, and our mean. So lots of things from one function. So we're just going to look at our test statistic and our p-value for this problem. Okay, so let's interpret those. Our test statistic was -3.46. So this means that our sample mean is about 3.4 standard errors below average. Seems pretty far to me. Let's look at our p-value. Our p-value is 0.0035. So this means if the coffees are 12 ounces on average, we would see a sample mean like ours or smaller in about 0.335% of our samples, which seems very unlikely. So that brings us to our next step, drawing conclusions. So here's our p-value again and our alpha level. Our alpha level is our significance level. It's kind of what we decide our cutoff point is going to be before we find a p-value. So because our p is less than alpha, this means that we're going to reject our null hypothesis. We think it's too unlikely to happen. So we reject the null and say that we do have evidence that the coffee shop is underfilling their coffee. We never say we have proof because 0.35% is very small, but it's not 0, so it can happen. Just to recap our steps, first we want to state our null and alternative hypothesis, then find our test statistic and p-value using R, and interpret those, and then draw conclusions. If you want to learn more about this, here's some resources. These top 2 tell us more about one sample t-test, and this bottom link tells you more about other types of hypothesis tests. Thanks for watching!